which is a valid question. As an interpreted language, you don't have memory concerns, you don't have seg faults, and I find for that reason particularly a lot fewer developers use debuggers when they're coding in Python, and PDB is less used than something like GDB or DBX on Sun. But if you're the kind of developer that can just write perfect code on the first try, this talk probably isn't for you. I personally put a lot of bugs in my code, not on purpose, just happens, I'm human. And printing really only helps so much. I find particularly when I'm stepping into some code that I haven't written, when I'm debugging someone else's code, I don't know really what's going on, what context I'm working in, debuggers can really help in cases where prints have limitations. With printing, you have to modify your source code. You have to change those modifications between runs. It's going to take a lot longer to do what you want to do. And I guess our goal here is just to get the job done as soon as possible so you can work on more interesting things, and debuggers will help you do that. So the developers of Python, ever since when the language was created, PDB it's part of the language. Ever since Python 1.4 in 1992, Guido himself said, like, we need a debugger that ships with every installation of Python. Everyone has it on your computer. You don't need a pip install or download anything. PDB comes for you. And it gives you the power that we talked about that prints, and just introspection of looking at your code has limitations. It lets you to inspect and change the contents of variables. It lets you to step through the code line by line to see what's going on. More complicated things like running code in the context of really the currently running program, executing different programs in current context, as well as like post-mortem analysis, figuring out what errors have been caused and how those errors got there. So let's figure out how to use PDB before we dive in. Just like how to run it. The first is as a script. pdb.py, as we've said, is available to everyone. If you use the -m command, it runs it as a module. And this is actually similar to what goes on if you invoke PDB from the command line, just the Python interpreter. If you import PDB and call pdb.run on your function, that's really similar to what invoking it as a module is doing. Anyone is free to go and dive into that source code, but it's just running it on your function. I find more common than these two is actually people using PDB like they would use prints. That's the most human thing to do, and probably the first thing you'll do if you move, if I hope you move from prints to PDB, you'll actually modify your source code to set a breakpoint in the source code. Which has, like, you see this line, import PDB, pdb.setTrace. Honestly, it's pretty ugly, but let's see it in a function. So I think most of us are developers here. We're familiar with a binary search. If you're not, it just finds if your target value exists in a sorted array in logarithmic time, better than comparing to every element and checking, which would take linear time. We see in our function, we just want to set a breakpoint as soon as we get there. Import PDB, pdb.setTrace. Again, it's sort of ugly. It still hasn't solved the problem of that we have to modify our source code every time we want to change breakpoints. We'll get into that. But there are some like ideological violations behind the problem of import PDB, pdb.setTrace. Earlier we talked about the Zen of Python, applying it to humans. I want to apply the Zen of Python to code. And these 5 things I find are particularly powerful Zen of Python comments or suggestions, and they've withstood the test of time. That this line is not very pretty. It's not simple, it's not beautiful, and it's not very readable. There's multiple ways to do it. Should you import PDB at the top of your function or class, or should you import it on the same line? And also, it's a special case. I personally didn't even know that the semicolon was in the Python grammar until like a year or a couple years into developing Python. So yeah, let's really figure out why this is like it is. Why is it that ugly? But also developers complain. They say it's a lot to type at 27 characters. It's really easy to typo, not beginner friendly. We're doing something as simple as setting a breakpoint. Why is it this complicated? It shouldn't be. And the creators of Python, that's one of the benefits of Python. benefits and drawbacks of that. Python is changing so quickly. Every year and a half, there's a new version, minor version released, and you have to stay up to date. But in 3.7, they address these concerns and introduce this new built-in function, breakpoint. That these two lines, import PDB, pdb.setTrace, and breakpoint, have the exact same functionality by default. We'll talk about how to change that, how to make breakpoint perform how you want it to perform. But if you just run under Python 3.7 and use breakpoint, then all of a sudden we don't have to type those 27 characters. We don't have to use semicolons. It's easier for everyone. And I also want to take a moment to explain one thing you can go into to learn more about these language features to become a better Python developer that I think has helped me a lot to learn is actually reading the PEPs. So if you want to learn, PEPs are Python Enhancement Proposal. They explain the reasons why and the reasons why, the implications, and how these changes are implemented. A lot of times Guido and top language maintainers and creators comment on them. It explains well written how everything is coming together. And so I would recommend, if you want to become a better Python engineer, you actually take some time to read some PEPs to really learn more about the language. This is PEP 553 that we're sort of diving into today with the breakpoint built-in function. So before we go into really what that PEP describes and how this is implemented, let's take a step back, do something simple. Let's just talk about how we can even use PDB to debug in Python. Like we said, a lot of people have the limitation of not even having this in their tool set, so I want to give everyone that opportunity to learn more about it. Again, let's take a refresh about the code example we'll be using, just a binary search. We're setting a breakpoint right before we do the recursion, and what will happen if we run this code? Since there is a breakpoint, it'll stop as soon as it reaches that line of the line 7 or 8, just after breakpoint. It actually tells us on line 8, we've stopped at if vals mid is greater than target, pausing execution here, so we really have the power to investigate how we want to. But we don't have the power yet, because we don't even know what commands PDB gives us. And we can get some help. If we just type help, then PDB tries to help us, but it doesn't do a very good job. It gives us 56 commands that we don't know what they're doing. We could type help and then a command, it would give us more documentation about that, but it's still a lot. It's really intimidating for new developers. So I'll just go through a few commands. Don't worry, we won't go through all of these today. We'll just go through a few to get you started. And the first thing we'd probably want to do if we run our code and stop at line 8 is just figure out where are we in our code. It shows that we are line 8 and the code that's going to execute next, but we really want to see what's around that. And if we type L stands for list. You can type L or list. There were 2 commands listed under help. It will just list 10 lines around where we've stopped. So we see we're in some function, we see what's going on. It's about to call binary search, but we don't actually know because 10 lines wasn't enough to give us the current function that we're in. And PDB, I should say, it prints the lines like this. This is exactly how you'll see it in the command prompt, but we'll give you just a little help to diagram where we are exactly. But we really want to see where we are in the program, what function we're in. The LL command was introduced in Python 3.2, which won't just print 10 lines around where you've stopped. It will print the function that you're currently in. So now we see we're in the binary search function. We see what's about to happen next. But we still haven't shown how to investigate things, how to step through, how to move through the code and really use PDB. All we're doing is printing lines of code. It's not that exciting. So let's actually investigate a little bit. PDB gives you the ability to do everything prints do. The first is just print the string representation of a variable. You can use the p command followed by whatever variable you want. If we want to see what the value of mid is, it shows us 5. If we want to show what the value of vals is, we don't need to use the p command. We can just type the variable name. It prints the variable. We can use args, which is a PDB function that lists the current arguments to the function that we're in. So we see this function, binary search, was passed vals, target, start, and end. Or we can even use and run a Python function. Locals is a Python function that will return the local variables of your function. So what we see here is that we're actually calling a Python function that's interpreted in PDB, and it's printing the returned value from that function. That's a little different from just printing a variable. Finally, PP is, it prints a pretty prints. PP pretty prints, so it's easier to represent dicks, to view your code and everything. So printing variables and changing the variables, you can change the variables, is cool, but we really want to move through our code, which is what we'll talk about next, moving through the code. The first command we want to talk about is the next command. We've stopped at line 3 in our program. If we want to just interpret and execute this line and move to the next, we can type N, which stands for next, move to the next line, and we'll go to the next line that's going to be executed if start is greater than end. If we type next again, since start is not equal to end, which we see 0 and 10, we will in fact move to the next line that's going to be executed if we type N, which goes to line 7. That's cool. Not that cool, quite honestly. It's pretty simple, but it is really powerful to step through your function and see what lines are going to be executed next, to see how the code is run. Even a simple command like next, incredibly powerful for you as a developer. We can continue stepping through next, and this is one thing that we should bring up. Next will not step into functions. Next will execute at the current call stack, not increment the call stack. So if we actually want to step into this binary search function, we have to use the step command. If we type S, which stands for step, we'll actually step into that recursion and go to where that function is called. S, if there's not a function being called, is idempotent. It'll just act as, sorry, not idempotent. It'll act as a next command. So S will act here as next, move to the next line. And if we step again, because there is a function being called, it'll step into that breakpoint function, which is a little bit terrifying for a new developer. We see we've stepped into some language implementation that we're probably not trying to debug. We probably take for granted that Python is well implemented, and we don't want to figure out what this handle from list function is doing. Let's get out of there. If we type return or R, then we'll go back, return from that function. It'll finish executing that function and return from there back to where we want to be. Cool. So continue is the last moving around command we want to talk about, which will continue execution until the program ends or we reach another breakpoint. Pretty straightforward. If we just type C for continue, it'll go all the way around until we've reached breakpoint again, which has happened because we've recursed. There's a couple other commands that I find myself using less frequently. You can check out the documentation for them. Jump is weird. I don't really recommend or see a reason for using it. It will move you around in your code and not execute the lines in between where you are and the place you're jumping to. Strange. But let's actually figure out how to traverse the stack, which is especially valuable in a recursive function like we have. We have this log function that's just logging some values. We don't know where log is called from. There's probably a lot of functions that are calling this log function. It seems really versatile, just takes whatever arguments you can give it and prints them. And if we type where or W, then we'll actually see all the function calls that led us to this current point. We'll take the liberty of just highlighting some of those to see exactly where they are. And we can actually go up and down the stack as we need to see what context these functions were called in. So if we type up or U, then we'll go up to where the log was called. We can type up again to go up even further, or up again to go up even further. We can type down to go down the call stack. But just moving up and down the call stack isn't that interesting. We really want to see what's happening at these calls. So if we're at the point at which we called log, we can print start and end. Simple, we already discussed that. If we type up and then print the same values, start and end, we see that the values have changed. Same variables, but they're in different contexts because we're at different points in the call stack. This is really cool. This means that we can change values at different points in the call stack wherever we want. gives you a lot of power to see how did I get here. That's really what traversing the stack gives you the power to do. So the next thing is we talked about import PDB, pdb.setTrace. We talked about the breakpoint function, but PDB gives you the ability to set breakpoints without having to modify your source code. It's really quite simple. You just type B and a position. The position can either be a line number, can be a function name, can be a file name and a line number, etc. B20 sets a breakpoint at line 20. bmain.py:20 sets it at line 20 in that file. Pretty straightforward. Or even at a function binary search. And before we know it, we have multiple breakpoints, and the only way to track them is through PDB. They haven't modified our source code. When you type B, it doesn't go in and modify the source code to add a breakpoint. It just sets it in the context of the PDB interpreter. PDB keeps track of this, sets some breakpoints. Cool. So we can actually condition those breakpoints, which is something we can't do through modifying the source code. You'd have to do some logic around the breakpoint to have a conditional breakpoint. It's simple as before. You just say B, the position, and the condition under which you want to set the breakpoint. And this is actually sort of cool. What if we want to set two, or really just set one condition, and we want to change the condition? We want to stop at in our function binary search. At first we say if start is greater than 0. We update that. We say, oh, I actually meant to say if start is greater than 5. Well, what's going to happen? If we type B, there's actually two separate breakpoints that have been set. Either one of them can be hit when we step into binary search. We probably didn't want to set two breakpoints. We might have wanted to. There are conditions under which you want multiple breakpoints for one line. You might have multiple conditions. Here we probably just wanted to update that condition. So we want to clear one of the breakpoints. Clear one, now we'll just have breakpoint 2. And we can actually update the condition on breakpoint 2 using the condition function. There's a couple other features of breakpoints that we can take advantage of, like temporary breakpoints that will only be hit and then cleared the first time that breakpoint is reached. You can disable and re-enable breakpoints that similarly you can't do with the import PDB, pdb.setTrace, or the breakpoint built in. I think we now have a good basis to go through and look at the improved functionality that Python 3.7 gives us. We talked about the update. We no longer have to write 27 characters, import a module, and set a breakpoint. We just have this breakpoint function. But what's going on? Under the hood, it's actually looking at a new environment variable that the language introduced. The environment variable is Python breakpoint. That you can set to a callable of your choice that will be executed and imported every time you reach the breakpoint function. There's some updates to the built-ins library and sys library that also handles the implementation of this. If you want to use this and you are using Python 3.7, it's pretty straightforward. By default, if you don't set the environment variable, it will default to import PDB, pdb.setTrace. It's not a one-line function. There are some, logic handling around it. Anyone is free to go and step in. But if you actually want to disable debugging, which is really powerful for things like breakpoints that you have accidentally released to production, if you set Python breakpoint equals 0, then every time you reach the breakpoint function, a breakpoint will not be triggered. And finally, if you want to customize or use a different debugging module, you can set the Python breakpoint to a callable of your choice. If you set it to foo.bar, then .baz, it will import foo.bar and then call baz on that module. So how does this work in code? We see how we can run it from the command line, but maybe you want to disable debugging in your code. You can actually import OS and then set the environment variable in the OS library, or the environment variable in your system, but you can set it from the OS library to 0. Or you can disable it for a function. This is a little buggy way to do it, to temporarily disable it while you're debugging a function. A better way to do it would be using a wrapper. If you have a disable breakpoints wrapper around a function, you can set the environment variable to 0, which will disable breakpoints for that function and any deeper functions that function is calling until you return from that function. Or you can even use a wrapper to set the breakpoint to whatever you want to say, around this function, I want this debugging module. So in conclusion, debuggers make your life easier. They make it so that you can spend less time debugging and more time developing. I think that nobody wants to spend any more time debugging than they have to. It's nice just to have code that works. And the breakpoint function helps you with that. It lets you, if you and your coworker each prefer different debugging modules, just use the breakpoint function, and you can specify with the environment variable whatever breakpoint module you'll be using for the context of that program. So thank you, and I'll take any questions. Two, one on the right hand.
Is this working? There we go.
Is it possible to set a breakpoint just on a condition, not on a specific line?
Like a, so
Like when a variable reaches a value of...
I'm familiar with what you're talking about. Something like a watching for a condition and breaking if that happens. So I'm positive with GDB, when you're debugging C and C++, it exists there, which is a feature. I'm also sure that if it doesn't exist in the PDB commands, there are aliases you could find online that would give you that functionality. One thing we didn't get the chance to discuss today was aliasing your own command to execute how you, I guess, any kind of feature you want. So I guess the answer to your question is there might be, and if there's not, you can definitely get that functionality.
With some great IDEs out there like PyTerm and such that have all this built in, is there any reason you would ever go back to using this command line?
Absolutely. That's a really good question. And a lot of developers these days do use PyCharm, which has their own breakpoint implementation where you like select a line that it's going to break on. You'll find when you're using PyCharm, it allows you to really use a command line interface similar to this. So what does that mean? That means that when you're using PyCharm in the console, you can print things similar to how this command line is working. So the answer to your question is there is a need to understand this even if you're using PyCharm. PyCharm uses these functions under the hood, and if you understand them, you'll be able to get the same functionality in PyCharm. Yeah, there's like no limitation of using PyCharm is what I'm saying. You can still do all these things.
Some examples of these alternative debugging modules?
Absolutely. One thing we saw was as we were stepping through the code, on one side of the screen there was printed code that we were highlighting where the code was. If you install PDB++ or PUDB, both of those will give you a nice representation of where you are stepping through the code. There's probably dozens of debugging modules that fit whatever problem you're trying to solve, whether that's over WebSockets, trying to debug in multi-threaded environments, which is a nightmare. The answer is there's quite a few debugging modules that fit different needs. One I find myself using is PDB++, which, as I said, is just giving you more power to see where you are in the code without having to type print or list every 10 seconds.
I've been using WinPDB, which is based on PDB for years.
Absolutely.
Great tool, and the thing is, it sometimes brings a warning saying that some sort of compatibility with some libraries. Can you elaborate exactly what's going on there? Because I never understood that this usually doesn't affect me.
So, good question. I will say I don't know all the things that exist on your computer's like path and the context that you're executing Python in. You'd really have to look at how Python is installed and how it sounds like WinPDB or whatever is installed to make sure those that conflict doesn't exist. I'd have to sit down to really figure that out. Mhm. Cool. And I guess the last thing I'll say is Bloomberg is hiring. If anyone wants to work as a software engineer, then please reach out. But thank you.